Okay, Assalamualaikum and good morning to everyone. So today we are from group 3 going to present about differentiation. Before we start our present, let us introduce ourselves. My name is Muhammad Afiq bin Usman and my matric number is 01DKM22F1017.
Hi, my name is Tarvin Raja, anak lelaki Chandrasekharan, and my matrix number is 01DKM22F1013.
And hi, my name is Muhammad Hafizul bin Hisham. My matric number is 01DKM22F1027.
Hi, my name is Muhammad Daniel Haikal bin Isa. My matrix number is 01DKM22F1111.
Okay, next I will explain what is the team roles and responsibility for our team. First of all, for Tavin, we'll explain about example of differentiation in real life and summary. For me, I will explain introduction and question and solution with graph. For Hafizul Hisham, he will explain about differentiation, rules, and question solution with graph. And lastly, for Daniel Haikal, explain about example of differentiation in real life and technique of differentiation. Okay, for introduction, differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in a function based on one of its variables. The most common example is the rate of change of displacement with respect to time called velocity. So I will pass to Daniel Haikal.
Okay, thank you, Afiq, for the explanation. Now I will talk about the technique of differentiation. First is basic rules of differentiation. The second is derivative of the trigonometry. The second is logarithm. The fourth is the exponential function. The fifth is second order of differentiation. And the next is the parametric equation. Then implicit differentiation. And the next one is partial differentiation. Then total differentiation. And the last one is application of differentiation, maximum, minimum, and point of inflection.
Thank you, Daniel Haikal. And now I will explain about differentiation rule. There are 8 differentiation rules in total which have different application. Which are first is the constant rule. This rule states that the derivative of any constant function is always 0. Second is constant multiply rule. The constant multiply rule states the derivative of constant multiplied by function is the constant multiplied by the derivative of the function. Third is the power of a power rule state that if is the base raised to a power is being raised to another power, the exponent and multiply and the base remain the same. The fourth is the sum rule. The sum rule states that the derivative of the sum is the sum of the derivative. Fifth is the difference rule. Say the derivative of the difference of the function is the difference of their derivative. And next is the product rule. Say that the derivative of the product of two functions is the first function times and derivative of the second function plus the second function times the derivative of the first function. 7 is the quiet rule. Say that the derivative of the quiet is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all divided by the square of the denominator. And the last one is chain rule. Chain rule is the use to find the derivative of a function that is the competitive of the two another function. These competitive functions are normally write f gx or gfx. Breaking a competitive function into simple function will make finding the derivative easier. Next, I will pass to Tavin Raja. Thank you.
Thank you, Afizul, for your explanation on differentiation rules. That was very clear. So next, I will be explaining about one of the question of application of differentiation in real life. So we can see the first question. You can see here shown that a tank, the width of the tank is 6 meter, the length of the tank is 10 meter, and the height is not given. So the question is, find the rate at which the height of the water rises in meter over h in the tank. If the hose is pouring water into the tank at a rate of 20 meter per h. So next, I will be tell you all what are the calculations for the question below. Okay, first we should find the dV per dt. The dV per dt is 20 meter power of 3 h power of -1. That is given in the question. So we should find the volume. Volume is the volume of the box is 10 times 6 times h. So you will be getting 60 h meter power of 3. So with this we know that dV per dh is 60. So after we have done everything, we should use the chain rule, which is dV per dt is equals to dV per dh times with dh per dt. So dV per dt is given, which is 20. dV per dh we have already find it, which is 60, and dh and dt that we should find it now. So when dh per dt is equals to 20 over 60, 20 over 60 will be 1 over 3. So we know that dh per dt is equals to 1 over 3, that we can simplify into dh per dt is equals to 0.33 meter h. Therefore, the rate at which the height of the water rises in the tank is 0.33 meter h. So that's all for my point. So next I will be passing up to Daniel so that he can continue with his second question.
Thank you, Talvin. Now I will give an example 2. The rate of change of the height Ht of the water in the tank is given by 0.3 t, where t is the time, which is taken in second. High water level inside the tank is 1 m initially. Find the height of the water level in the tank after 5 seconds. The rate of change is dH dt 0.3 t. When t equals 0 second, H equal to H equal 1 m. We need to find the value of H when t equal 5 seconds. To get H, integration is required. Substitute H equal 1 m when t equals 0 second. To get the constant value for the intermediate divisor, let's find the value of the water value t equal 5 seconds. Implement strategy. Given dH per dt equal 0.3 t, then Ht equal 0.3 t dt. 0.3 t power of 2 equal to plus c. When t equal 0, hash 0 equal 1, 0.3 bracket 0 power of 2 per 2 plus c equal 1. Then hash t 0.3 t equal power of 2 per 2 plus 1. When t equal 5, hash 5 equal 0.35 power of 2 per 2 plus 1 equal 4 3 per 4. Make a reflection. If hash t equal 0.3 t per 2 plus 1, ds dt t equal 0.3 t equal 2 per 2 plus 1. The equal is 0.3 t.
Thank you, Danny Haika, for explanation. Next, I will go to question and solution. First question is y equal to x power of 3 plus 5x minus x. And second question is y equal to negative x power of 3 minus 6x power of 2 plus 4. The question is use differentiation to find expression for dy dx. Second is find the coordinate of any stationary point on the cruise. Third is calculate the stationary point on the graph. Fourth is determine the nature of any stationary point that found in the park, and justify the answer. And 5 is sketch the graph of the cruise. Next, I will go to first question. First question is y equal to x power of 3 plus 3x minus x. And we will do dy dx, and we can get 3x power of 2 plus 10x minus 1. And we can go to dy dx equal to 0. 0 equal to x 3x power of 2 plus 10x minus 1. We will find the x, and x equal to 0.097 and equal to negative 3.431. And when x equal to 0.097, y equal to x power of 3 plus 5x power of 2 minus x. And we can we can get y equal to negative 0.922. We can Google, and we can do when x equal to negative 3.431 and negative 3.431 power of 3 plus 5 negative 3.431 power of 2 minus times negative 3.431. The coordinate are we can get 21.5, and we can therefore the first coordinate is 0.0997 and negative 0.2922, and negative for the second coordinate is negative 3.431, 21.9. Therefore, there are two stationary points with 0.097, negative 0.922, and negative 3.431, 21.9. Can do the next question is to find y-intercept if x equal to 0, then y equal to 0 power of 3 plus 5 0 of 2 minus 0, and we can get 0. And y-intercept is 0, 0, 0. To find x-intercept if y equal to 0, then 0 equal to x power of 3 plus 5x power of 2 minus x, and you can get y-intercept 0, 0.193, negative 3.193, and 0. And 5 we can do dy dx again, and can get 6x plus 10. When x equal to 0.097, and we can get 10.582, and we can go next. When x equal to negative 3.431, and we can get negative 10.586. For the more point is 0.097, negative 0.922 is the minimum point, and the point negative 3.431 and 21.8 is a maximum point. Next, we go to Afid for the second question.
Okay, thank you for Hafizul for explain the question 1. Now I will explain how to solve the problem question 2. The question 2 is y equal negative s power of 3 minus 6s power of 2 plus 4. So the first of all, we must differentiation the question, and the answer become negative 3s power of 2 minus 12s, and then dy dx equal 0. So the 0 the 0 equal negative 3s power of 2 minus 12s. Use the calculator to find EQN, and you can get the answer is s equal negative 4 and or s equal 0. And then the next step is when s equal negative 4, we must put s become the negative 4. So y equal negative time negative, negative 4 power of 3 negative minus 6 bracket negative 4 power of 2 plus 4, and we can get the answer negative 28. So next, when s equals 0, y equal negative s power of 3 minus 6 negative s power of 2 plus 4. We must change the s become 0, so we can get the answer is 4. So therefore the coordinates bracket negative 4 comma negative 28 and bracket 0 comma 4. Then therefore there are two stationary point which bracket negative 4 comma negative 28 and 0 comma 5. And then negative s power of 3 minus 6s power of 2 plus 4 to find y-intercept. If s equals 0, then y equal negative bracket 0 power of 3 minus 6 bracket 0 bracket power of 2 plus 4 and become and answer is 4. Next y-intercept equals bracket 0 comma 4 bracket. To find s-intercept, if you y equals 0, then 0 equal minus s power of 3 minus 6 negative s power of 3 minus 6 s power of 2 plus 4, and the answer is s, and we can get the s-intercept, and s-intercept equal bracket 0.841 comma z negative 6.056 comma negative 0.7825. After that, dy ds equal negative 3s power of 2 equal minus 12x. D power of 2y per ds power of 2 equal negative s negative 6s minus 12. So when s equal negative 4, we must change the s like negative s bracket negative 4 bracket negative 12, and we can get the answer 12 is more big from the 0, and then when s equals 0, negative 6 equals 0 minus 12, and we can get the negative 12, and is smaller than 0. Therefore point brackets negative 4 comma negative 28 is a minimum point, and point for negative bracket 0 comma 4 bracket is a maximum point. So this is a graph for the solution question 2. The lastly, for the summary will explain by Tarbi.
Thank you, Afiq and Afizul, on your wonderful explanation on question 1 and question 2. So, I will be shortly conclude what are our presentation that we have presented to you all. First, we have stated you what are the types of differentiation. Second, rules in differentiation. Thirdly, 2 example questions of application of differentiation in real life, and 2 questions with solution and graph. So next, I will be end up with telling the summary of this presentation. Differentiation is done by applying the techniques of known differentiation formulas and differentiation rules in finding the derivative of given function. The process of finding the derivative of a function is called differentiation. The 3 basic derivatives are differentiating the algebraic functions, trigonometric functions, and exponential functions. We use differentiation formulas to find maximum or minimum values of a function, the velocity and acceleration of moving objects, and the tangent of functions. The differentiation of a constant is 0 as per power of rule of differentiation. So in the end, differentiation can be very useful in engineering field to solve many engineering related problems. That's all from us. Hope this presentation fulfill all of the audience, and we hope we give the best to all of you. So bye.
Bye.